Okay, sir.
Khalid Nenaey, I hope I'm pronouncing that right. He's a colonel engineer, graduated from Military Technical College in 1999.
Yes,
His
sir.
specialty is mechanical engineering and works the roads brigade in charge of maintenance of heavy vehicles. He is a master's student, and he's calling from Alexandria University in Egypt. Okay, go ahead, Khalid.
Okay, sir. Can I begin?
Yes, please.
Okay, sir.
When
Good
you're
afternoon,
ready.
sir. Good afternoon, sir. I am Khalid Nenaey. I am a master student under the supervision of Dr. Yahya Dirini and Dr. Sadiq Kassab in Alexandria University in Mechanical Engineering Department. I will introduce a presentation about a performance evaluation of hybrid vertical axis wind turbines. The features, as we know, is concerned about the introduction of the presentation, and then we will discuss the objective, and we will talk about the numerical setup, the results, and finally, the conclusions. I will concentrate in the presentation in the vertical wind turbines, and our aim is to enhance the efficiency of it. As we can see that there is advantages and disadvantages of each of the horizontal and the vertical axis wind turbines. The advantage of the vertical axis of the horizontal axis wind turbine, as we see, it has a high efficiency and can flow out of the wind to reducing wind speed. It's high power reproducing turbine caused by nearby structure, and it has also a disadvantage, like its tower mounting making, and it has a maintenance more difficulties. For that, required large structures, and the installation requires heavy equipment. The vertical axis wind turbines here has advantages and disadvantages. The advantage of it has a ground mounting mix, maintenance easier for it, and it can be installed in the area of the wind fairing and the high wind speeds. It make low noise and it will require the low starting speeds. But it has some disadvantages like the low efficiency of it, and it may require the guys to support the rotation axis. This disadvantages here make many researchers to research about how to improve the efficiency of it and find the solution for its obstacles. The graph shows different type of the wind turbines, which are first of the Savonius wind turbine, and then the horizontal wind turbine, and then the last the Darius wind turbine. The Savonius type depend on the drag force. On the other hand, the horizontal type and the Darius types depend on the lift force. We can see from the graph that the Savonius turbine has the lowest power efficiency, while the Darius turbine is better than it. And the horizontal gives us the highest coefficient of power. According to that, sir, we will combine the Savonius turbine and the Darius turbine together to get it highest performance of them. The major types of the vertical axis wind turbine are the Darius type, which depend on the lift force and also has a good efficiency, but it cannot be a self-starting turbine. But on the other hand, the Savonius turbine using the drag force to create rotation, and it has a good self-starting ability. To achieve our To achieve our object, we will introduce 3 different types of vertical axis wind turbines. Like the vertical, 3 types of different vertical axis wind turbine. The Darius type here, which is a 2-stage turbine, and also a hybrid, and so and the horizontal axis wind turbine, and there is a hybrid between them. It's Savonius, which is inside the Darius turbine cell. To simulate the flow around the blade of the turbine and to predict its performance, we creating a computile domain as we shown in the figure. And to eliminating the wall effect of it, we put the turbine away from the domain wall and have a sufficient distance behind the turbine is to left to allowing the flow to recover before the domain outlet cell, as we see in the figure. In this figure, we show that we concentrating the mesh around the high gradient zone to capture all the gradient around the blade in order to assess low cost and the high quality of the turbine. And then the mesh was refined until the maximum skewness it be 0.9000 was achieved. To be sure that our solution is not depend on the size of the mesh, we make the grade independence study. We increasing the number of the mesh nodes too much, and we will show that the increasing of the number of the mesh nodes too much may not give a sufficient change of the simulation, but it only consuming the time, so that we make the grid independence study to ensuring these points here. And then we make, to confirm our search here, we make 2 simulation. One, the time step, one of them is the time step is to taking 2 half, and then from the first case here, and the second here is we increasing the number of the nodes to the twice of it. To show that the last 2 cases seems to approximately close from the first case here, as we see from the table. The simulation model cell we used the second order interpolation method to be to our solutions here, and we realize the K epsilon model with enhanced wall treatment were applied to the model to make our results. The K epsilon model cell has proved to be reliable and more efficient than other models that we can use it. As we can see from the diagrams here, when the wind is perpendicular to the wind blades here, it will make the maximum coefficient of the moment here will be, and the maximum coefficient of the moment. And when the wind with and will make 45 degrees here with it, it will give us the minimum coefficient of moment here, as we show that in the diagram. We also make a comparison between variation of the turbine here, and we can note from these diagrams here that that has shown that because the Darius turbine, the Savonius turbine here is the lowest power coefficient, and then the Darius turbine here is bigger than it, and the Savonius plus Darius, which is separately greater than, but the highest efficiency here we can make it by the hybrid, which is Savonius inside the Darius here, as we shown that in the diagram. There is also a variation between, there is also coefficient of performance or variation between the tip speed ratio between the three different types here, the Savonius, Darius, and the hybrid here. The wind speed is fixed at 6 meters per second here, and the figure shows that the ability of Savonius turbine of self-starting because it has high CCM and the lowest tip speed ratio. But also we can see that the Darius rotor has the lowest CCM at lowest tip speed ratio, and as it depends on the lift force. Also, for the hybrid turbine, its drag type blade can be self-starting at very low tip speed ratio here. The hybrid turbine performed better than the individual Savonius and the Darius turbines. This figure here will show us that the flow is trapped within the turbine blades, and thus results in a substantial reduction in the output power compared to the hybrid turbine. And this diagram shows us that we told you here. When we compare it with this figure, and this figure with that in the middle, we put the Savonius in the middle place of the Darius turbine, which would block the flow and direct it to the side of the Darius blade. And we consuming there, and we can conclude that the Savonius turbine here will serve as a deflector so that the Darius blade could perform better at higher values of tip speed ratio. So the hybrid turbine performance is enhanced by the advantage of the deflector, which we said that is the Savonius turbine set, which will make the deflector to the Darius turbine to enhance its performance. We can conclude that, sir, the Savonius turbine is self-starting and it can producing the highest CM at low tip speed ratio. The Darius wind turbine sir can spin at higher blade speed than the wind speed at constant wind speed and different tip speed ratio. The hybrid turbine perform rather better than the Savonius and the Darius turbines. And also the very important point here at the Savonius will act as a deflector for the Darius turbine to enhance the performance of the hybrid turbine here. This study indicates that the hybrid vertical axis wind turbine, whose lift type and drag type, when combined with each other, can achieve highest starting torque. Then, that a conventional Darius and the Savonius types itself, besides at the highest tip speed ratio, the hybrid turbine takes the advantage of its drag type blades and a guide for the flow to the Darius turbine. Thank you, sir, and I will wait for any question from the members.
Great presentation. Thank you, Khalid. Yeah, let's wait a few minutes to see if anybody on the live stream asks some questions.
Okay, sir, I'm with you.
I have one question. Can you comment on the other benefits of the vertical axis turbine over the horizontal axis turbine?
Benefits of? Excuse me, can you repeat this question again for me, sir? Benefits of what, sir?
Yeah, sure. I see you listed some advantages and disadvantages of the vertical axis wind turbine.
The vertical wind turbines, you want the advantage and disadvantage of it, sir? Yeah.
I'm wondering, it has lower efficiency, but can you get more vertical axis turbines in a square footage in an area than horizontal axis turbines?
We compare the vertical axis wind turbines has two, as we told you, has two kinds, the Savonius and the Darius. Most of the Savonius turbines here has a lot of designs that the Savonius turbine can also have 3 blades, and we comparing this stage here with another design. Like the Savonius has one stage here with 3 blades, and also Savonius turbine has 2 stage with 3 blades also in all the stage of them. As a result of our combination says that the Savonius turbine with 2 blades is more efficiency than the Savonius turbine with 3 blades. Because when we put 3 blades inside the Savonius turbine, it will not give us high efficiency for it. And also the 2 stage of the Savonius turbine will give us the highest efficiency of the turbine. So we can conclude that the Savonius turbine with 2 stages here has more advantages and give us highest power than the Savonius turbine with 2 stages, and also the Savonius turbine with 1 stage with 3 blades. Also, we compare our results, which is the Darius types here with the H type. This types here will give us high power than the other types, because the types of the egg beta here can give us more efficiency, but it will consume a lot of money to construct it, and compared between them, it will not give the highest efficiency than it. So we can using the H types here with 2 blades, with 3 blades also.
اشتغل يعني؟ يعرف؟ شغال من بدري.
Yes, would you like to add something? Go ahead.
I'm with you, and that's enough, sir. If are you waiting for any questions, sir?
Okay. Well, thank you for that answer.